All right, let's now go back to Happy Land and do an example of var of par. In particular, no pun intended, find the general solution of y double prime minus 2y prime plus y equals e to the t over 1 plus t squared. And the first step is to find a homogeneous solution. So homogeneous solution, meaning solve y double prime minus 2y prime plus y equals 0. And this you can do using the auxiliary equation. So, which is r squared minus 2r plus 1 equals 0. That's a perfect square. So r minus 1 squared equals 0. And so r equals 1, which is repeated. Repeat it, and then just like Michael Jackson says, repeat it, repeat it. Which tells you that our homogeneous solution is ae to the t plus bt e to the t. Okay, there. And now we want to use var of par. Var of par. Again, remember, we want to solve y double prime minus 2y prime plus y equals e to the t over 1 plus t squared. And remember, big trap in var of par, you want it to be in standard form. Remember, meaning the coefficient of y double prime is 1. So this is in standard form here. And since it's in standard form, we can proceed. And remember, what is var of par? It says, assume y of p is the same thing as the homogeneous solutions, but the coefficients, they're functions now. So ut e to the t plus vt t e to the t. Again, I would like to remind you once again that in var of par, we do not care about resonance. It takes care of itself. And then use the var of par equations. So we have e to the t, t to the t, and then the derivatives. So derivative of e to the t, it's itself. And derivative of t to the t, turns out, is t plus 1 e to the t. And this just follows because t to the t prime is e to the t plus t to the t. So 1 plus t to the t. So this is the Wronskian matrix. And then remember u prime and v prime, because we're integrating later, and then 0 and inhomogeneous term. So e to the t and then 1 plus t squared. All right, and now we want to use Cramer's rule. So let's first look at the denominator, so the determinant. Again, you will see it makes it easier. So let's do determinant of et. Et wants to go home, te to the t, and then t plus 1 e to the t. Okay, so this becomes e to the t times t plus 1 e to the t minus te to the t, and then e to the t. And you will see the nice thing is it simplifies. So this becomes, if you want, t plus 1 e to the 2t minus te to the 2t. And then t plus 1 minus t is just 1. And so you just get e to the 2. So the denominator will always be e to the 2t. And now let's use Cramer's rule. So what does that say? So u prime of t is the ratio of two determinants. The denominator is the determinant we found, which was e to the 2t. For the numerator, same thing, but we replace the first column by the inhomogeneous term. So e to the t, 1 plus t squared, and then t e to the t. E to the t, and I think t plus 1 e to the t. E to the t. And then this just becomes 0 minus t e to the t, and then e to the t, 1 plus t squared over e to the 2t. And then this becomes, I think, if you want 1 over e to the 2t, and then minus t e to the 2t over 1 plus t squared. And the exponential terms cancel out, and you end up getting minus t over 1 plus t squared. And that's the t. So that's u prime, which we'll integrate soon. But now let's deal with v prime, because c'est la v prime. And same thing, except you replace the second column now by the inhomogeneous term. So e to the t, 0, e to the t over 1 plus t squared. And then in same denominator. So this becomes e to the t, that's e to the t, 1 plus t squared minus 0 over e to the 2t. And this becomes 1 over e to the 2t, e to the 2t over 1 plus t squared. Once again, the exponential terms cancel out, and this becomes 1 over 1 plus t squared. Almost done, I promise. So we found u prime and v prime. So now let's find u and v. So I believe u prime of t was minus t over 1 plus t squared. So u of t is the integral of that minus t over 1 plus t squared dt. And for this, if you wish, you can use a u sub. U is 1 plus t squared, and sorry, that should be u of t. Again, you can use a u sub, and then you then get u of t, I believe, is minus 1/2 ln of 1 plus t squared. No absolute values because the stuff inside is positive anyway. And same thing now with v of prime of t. So v prime of t is 1 plus t squared. So 1 over 1 plus t squared. And then v of t is integral of that plus t squared dt. And remember, this is the angry arctangent. Oh, very good. We found our u, we found our v. So now we can build up our solution. So step 3, I think it's step 3. Yeah. Solution. So our particular solution, first of all, was, again, u times e to the t. So in this case, minus 1/2 ln of 1 plus t squared times e to the t, and then plus v, so arctangent of t, times t e to the t. Again, this first thing is u of t times e to the t, and the second thing is v of t times t e to the t. And then, remember, that's not the end. We have to find a general solution. So y of t is the homogeneous solution plus the particular solution. And so y of t becomes ae to the t plus bt e to the t minus 1/2 ln of 1 plus t squared e to the t plus arctangent of t e to the t. And once again, good luck guessing that with undetermined coefficients. This is what makes var of par such an amazing technique.